Doing good. So in this video, I'm going to show you how you can get started with attribution modeling using GA4 data within BigQuery. Now, there are a couple of nuances here. First of all, you have to get the data from GA4 within BigQuery, right? Now, I'm looking at what's called the public data sets within BigQuery. So this is a BigQuery account if you are not familiar with it. And you'll see here on the left hand side, this is the data set, and within that you will have individual tables as goes the BigQuery architecture. This is a particular table. So this table, as you can see, is called events underscore 31st of January 2021. So that's how these are named. Now you'll see that there are a number of tables here, quite a few dates available here from 2020 and 2021. So what I'm showing you here is basically the data for this particular date, right? And for this particular date, you have all these. I mean, each of these tables basically have all these fields, and that's how the data is structured. So I can just move to any other date. The field names are going to remain the same, but it's going to be a different table altogether. So you can preview this under this section here, and you will see that essentially it has the event date for each row, and it also has the event timestamp. So the date and timestamp are separately present in the data set. And so there you go, event date and timestamp, and then you have the event name. So it's basically filtered down or drilled down by these different values from that's how it comes from GA4. This is raw data, by the way, and that's the advantage of using it within BigQuery, of course, which you can potentially then use for attribution modeling. There are some nuances and there are some caveats which I will probably touch upon this video or on in future videos. So you have a lot of other values here in the form of columns, parameters, and user IDs, and basically device names, and of course the sources and mediums, which are there as well, like in traffic source. So this is called nesting. So all of this is nested together. Different columns within traffic source. Here, for instance, there are different things nested within e-commerce, a lot of them, all product related, SKU related information, and then you have some item related information here. So all this important information is present in the form of fields. Now you have to work on this data set using SQL query, and after that you will have a certain output, and that output is actually going to look like this. So the reason why I have what I've used is actually a dummy data set, and the reason why I'm doing that is to give you a clearer picture, because using this public data set, it wasn't really going to be as fast and as easy to present. But eventually the outcome is going to look like this. So you will have a table which will consist of event time, which is basically concatenating, as you can see, the timestamps and the date. And then you will have the channel, the user IDs, revenue, and conversion. These are the different columns. I'll see that the channels are essentially, they are defined in certain they are basically defined in certain ways within BigQuery's data itself. And that actually depends on what your data set contains, right? So this will be depending on what the values are within the traffic source. And once those channel names have been taken, have been sort of aggregated, you will get the data for each time and date in each row, and a certain channel, uh, and a user ID. So each user basically might have the idea is that they might have a journey which consists of multiple channels, right? So the user ID can get repeated, as you can see here. So user one has is appearing 3 times here, and it is actually sorted. If you look at the data and you understand a bit of concepts of coding, so it's actually sorted by user ID and time, event time. So basically, for the way this table will go is, for each user ID will have different timestamps and dates, and once that user is complete, then the next user is going to be shown here. So that's how it is working, and the different channels will be listed as well in each of the rows in the journeys. Now purchase has been done separately, you'll see, and of course that's not a channel, but this is actually a key point here, and that's how this entire thing is going to work. If you don't have purchased, it will be difficult for you to earmark that, or sort of highlight that in your attribution path modeling, which is the next thing, the next stage in this process. So you will have to earmark whenever there's a conversion as purchase, and this is basically to sort of indicate that a particular journey has come to an end, because the journey only exists up to the point of making a purchase. After that, you consider that as a break in the journey, right, and a new one starts. It could be by the same user, and of course if the user has changed, of course it's going to be a different journey. So we're going to come to that. So that's, this is basically laying the groundwork for that by having purchased separately earmarked as a channel. And obviously you see that whenever there's purchase, you will have a certain revenue and a conversion. For the other cases, it's either revenue is either undefined like NaN, or conversion is zero. So this is basically the aggregation that you will have from your table. I obviously couldn't show the actual data sets with which I work, but essentially once you have exported GA4 data within BigQuery, and you have carried out a certain transformation, um, you can let me know if you're interested in that SQL code. But once you have the SQL code, this is exactly how the output is going to look like in the first phase. Now comes the next phase of this process, which is where you carry out the actual path modeling. And I'll show you the output first as to what we are trying to do. There are two outputs to this. First, you visualize a channel frequency. This is just for analysis purposes, where you just look at the information from different channels, like how much frequency, what is the frequency of users going through different channels. Remember, this is across different users. So obviously in this case we have the frequency of purchase being the highest in this dummy data, and you have other channels like other paid search, social, organic, and affiliates. And this is the attribution path, and you might be familiar with this, actually available within BigQuery, within GA4, sorry, right? In the UI, you must have seen that within the attribution model section. This is where the within the attribution path section rather, and you have the different paths, right? Each touch points within the user journey, as you know sort of concatenated, or joined together, and each of these are obviously independent or unique points within the touch points, one after the other. So there is also an ordering, and this basically has been aggregated through other columns like conversions, and total number of null values, and total conversion value. So that's basically the output we are trying to get. And after this comes the actual attribution modeling. So in this video, I'm only going to cover the part about what you can do to get started with the attribution modeling based on GA4's data available in this format. So this is sort of the stage that I'm going to discuss, because there's so many stages in this. There are so many nuances, and it's so easy to make mistakes, um, and to actually not even be aware of them potentially. So now in this next stage, the first thing that you do is I showed that there's a channel distribution plot. Now you basically do what's called the identification of new journeys, and I'm going to talk about it a little bit for a couple of minutes in details. After that, the next step is getting, and this is the toughest part, by the way, the identification of new journeys. This logic was tough, and this is again not exactly my piece of code, but to come up with this idea, and you have to understand this logic if you have to also tweak it. So it's actually important to know the concepts very well, wherever you're applying this sort of a code. Again, this concept could also be potentially done within SQL itself, like within BigQuery using SQL, but I've done this using Python because I'm just more familiar and more comfortable using that. Then you have the last conversion time per journey. um, as you understand from the name itself, this is the first step was to identification the new journeys, and then you identify that the conversion time, when actually the new journey ended, because it resulted in a conversion. And then you also look at filtering. You do a filtering of last 30 days of conversion. Again, this is of course something that can be customized. You can build paths without the purchase channel, and this is the important part. This is what I was talking about from the last table as well. Like, you have purchased in each channel, and then you actually, at this point, you take out all the other channels instead of purchase, because those are the real ones that you want to have a path for, right? So that's what you have done, like channel which does not equal to purchase, and then you actually aggregate the different paths together, right? So that all the path events, those you are just using group by, so you're essentially aggregating, and then you are removing the consecutive duplicate channels, because you will have duplicate channels as well, and consecutive ones, right? Duplicate ones is fine, within a particular overall path, but it should not be one after the other. Like, suppose a user has gone through, say, organic search, and then paid search, and then maybe affiliate, just giving an example off the top of my head. But yeah, those repetitions one after the other, that doesn't make sense, right? So you have to get rid of that. That's what's being done here. And then you have conversion and revenue from the last row of each journey. So this again, if this means essentially that it has ended in a conversion, one particular journey, and so you're trying to get the total conversion and the revenue from that journey. So that's what it's trying to do. And then you're merging it, right, using a left join principle, all the paths together, and that's pretty much it. I mean, then you obviously mark anything that has not resulted in a conversion as null conversion value. Then you have a final attribution table, which is sort of aggregating together all of the conversion null value and the conversion numbers. So these together ultimately result in this table. So that's what's really going on. I hope the logic was clear of the flow, but I think that the most critical part here are these 4 lines of code. I've been talking about this for a couple of days now on LinkedIn. I don't know how many people have actually observed that, but I think this is definitely more important to talk about. So I'll just drill down a little bit now on those 4 lines of code, and I'm going to talk about what they are really doing. So the first line is basically trying to define whether or not it's basically trying to create a binary column of zeros and ones, which defines whether or not a new journey has started. And that's basically by looking at whether or not there's a conversion in the previous row. So that's what this shift is doing. So you'll see the result here talks about that it's a new column initially set to 1 if the immediately preceding row resulted in a conversion. See, that's what I was saying. Like, if the previous rows resulted in a conversion, that's what you would then you would essentially set it to 1. And I'll just show a visual diagram here, a visual representation of this. So if you look at this here, this is basically user A's timeline, user B's timeline. So in this time and date, so just imagine this is also date, it's only the timestamp here. So no conversion here, and there's a journey ID 1, and then a conversion takes place. Then it's still the journey ID 1 at this stage, but at the next phase it's a new journey. It's the same user, remember, because we sorted by the same user, because we sorted by both event time and the user, sorry. And this is where a new journey starts, because there was a conversion in the previous row, right? So since conversion was 1 here, and you shift by 1 row, and then you start a new journey. So that's basically what is happening, and the same is actually happening in this case also, that the journey ID, see, the journey ID updates itself the moment there's a new conversion, right, or a new journey starts rather. So that's the first line. The second line is essentially setting a cookie change parameter. So a cookie change is happening when the user ID is different. So there are 2 ways now to identify a new journey, right? And that completely makes sense. So either the user is starting a new journey, the same user, or it's a completely different user, right, in your session, in your website session. So if that's the case, like if you know, so the cookie change is essentially a boolean series, which is either set to true if the user ID in the current row is different from the user ID in the previous row. So the cookie obviously changes if the user has changed, right? So again, like I was saying, so our table, remember, after the manipulation from the raw GA4 data, looks like this. So your user 1 ends up at this point, so that is where your cookie change triggers, right? So that gets set to 1 whenever the user ID is different from the user ID in the previous row. So this is a common way to detect if a user, um, if a different user or a new session has been started by the same user, and then when that's when the cookie gets reset. So there's also the third one now. So that's df.lc cookie change is new journey equal to 1. And what is this is doing is this line actually overrides the previous assignment. Because remember, in the previous assignment, what was happening is whether or not it's a new journey was being determined by the fact that whether or not there was a conversion in the previous row. In this case, irrespective of whether or not, see, regardless of whether or not a previous conversion happened, if the user ID changes, it unequivocally marks the current row as the start of a new journey. Okay, so again, coming back to this example here, this is the start of a new journey. The user ID remains the same, it's the same user. um, in this case, sorry, it's the start of a new user here rather, yeah. So there was no conversion in the previous row, right? But you have a new user starting here, right? So once that happens, your journey ID updates itself, so it's a new journey. So that's what the third line does, and you can see it's so conceptually important, right, to understand this. And getting these steps correct is fundamental to actually getting the the structure for the attribution model ready. And the final step is where you have the journey ID, and you actually take a cumulative sum of the new journey ID. So that's what gives you the actual journey ID at that level. So for instance, you have multiple changes in the journey, right? So that's why you have 1 2 3, and you start another journey here because there was a conversion in the previous step. So this is what it is doing essentially. It's taking a cumulative sum of the journey IDs up to that point. So whenever it is 0, the cumulative sum remains the same, right? Because you don't have a new journey yet, so up to that point the journey ID remains the maximum of what has already happened up until that point, right? So again, just to give an example here, since in the previous step it was 0, it remains 3 here. It's not getting added, but 1 is getting added to it the moment you have a conversion in the previous step. So that's how it is getting updated. So that's it. I mean, this 4 lines of code, I think, are fundamental to understanding what was being done in order to come up with this sort of a structure. This is basically ready now for processing for attribution modeling. And why this is important, I can share this doc. This is very easy to understand, but we can read through it. Like, this is important for for attribution modeling because it is defining the scope of a journey or session. If it's giving you the ideas about what's happening post conversion, user and cookie change, that also is being tackled by it. And it is grouping together relevant touch points, obviously, showcasing the events in a sequential manner. It is isolating the conversions, because you can link specific conversions to the sequence of touch points that preceded them within the same journey, like I was just showing, using that visual representation as well. And then you obviously prevent misattribution in multiple ways. So for instance, if you might just without proper journey segmentation, you might attribute a conversion to touch points from an entirely different user, right? So you don't want to do that. You want to ensure that uh, you just maintain the same user, and you don't confuse between two users. Just because the journey is different, the user can still remain the same. So there are multiple ways this can help prevent misattribution, and then it obviously ultimately enables you to apply your different models. Like, this can be first touch, last touch, linear, data driven models like Markov chain. So I'm going to talk about these different models as well. And I'm going to talk much more about GA4 and BigQuery attribution. I see some rising interest in this, and it totally makes sense. And I will just wrap up with this discussion now quickly. Um, See, the point is that BigQuery is incredibly powerful. There's absolutely no doubt about that. There are very big sort of data data warehouse or data lake brand, I mean, companies and applications. So you can, you can look at Snowflake, for instance, and Databricks. The advantage of BigQuery is that, first of all, it's much less costly, and it's much more accessible, therefore, to smaller and medium enterprises and brands. On the other hand, BigQuery is only going to aggregate data from different sources. How the quality of that data is in the first place is something that BigQuery doesn't necessarily have any capability of changing. Now, BigQuery, therefore, using GA4 data, is incredibly useful. The GA4 BigQuery combination is incredibly useful for, say, things like SEO, or trying to understand how your website is performing with respect to different audiences. And so that those sort of analysis is incredibly strong using this combination. The problem with even with paid, I mean, there are aspects of even paid marketing that can be useful, but the problem really arises when you try to use this combination for attribution modeling. I think that's where it starts getting into the gray zone. And I don't think, I'll be super honest about this, I don't think this is the best way to go about it. If you ask me, like, what is the best way to go about attribution modeling, I don't know, to be honest, because there are obviously already third party vendors out there, attribution tools. And I think this simply doesn't make any sense to reinvent the wheel. But the point here is, of course, if you have a great idea for creating a new attribution model, then great, go ahead and try and do the custom attribution modeling using this combination. The problem is with GA4's data. How much are you going to trust it? This is, of course, raw export within BigQuery, that's true, but at the same time, it has its own issues. Like, it's not going to be able to tell you information that is beyond clicks properly, right? And therefore, you're going to be finding it difficult to create an attribution model out of just GA4's data within BigQuery. So I would suggest that, I'm not a big fan of attribution modeling in precisely because of this reason, because data collection itself is so tricky. And conversion tracking methodologies are they have a lot of loopholes these days. And attribution modeling has a modeling aspect of it. And if you're talking about modeling, to be honest, I would much rather go for things like um, testing designs, experimental designs, and in a longer range, marketing mix models. Those are far better, more robust approaches to understanding impact and attribution. I mean, that's not really the word I will use there, but you get the drift, right? I mean, it's a better way to do attribution using non multitask attribution methods. But nonetheless, if you still want to get your hands dirty, this is a method to this can be a good way to get started with it. The only problem is that attribution modeling is incredibly complex. It's very mathematical, and you can't expect non-specialist teams to come up with this properly. I'm 100% certain about that. I've spent a lot of time over the last few years trying to work on these things. I've read through a lot of mathematics. I've read through Bayesian statistics and a lot of advanced stuff in linear algebra. You need to know all those stuff, and I'll prove it in upcoming videos as well. And I think there's a lot of misinformation which really needs to be dispelled around this. But nonetheless, yeah, all of those are upcoming. But I just wanted to show that even in the data preparation phase, there's just so much that goes into it, and therefore so much that can also go wrong. Hopefully this was useful. If you have any questions, like always, do leave in the comments. I am always open to discussions. And thanks for watching. I'll see you in the next video.